Is my screen visible?
Yes.
Okay. Okay then. So this is our third tutorial of the subject technologies for clean and renewable energy production. And the content for the today's tutorial would be, as I have uh, in the last two sessions, as we have talked about coal and coal and the various techniques of energy production from coal. So after that, we are switching to petroleum. After coal, this is one of the largest source of energy in the world, being coal the largest. So the content would be including, firstly, we'll be talking about its introduction, what is coal, about its origin, its availability, then its various types and classifications, and its pricing uh, and issues related to the energy production from coal. Then secondly, its various properties, impurities found in crude oil, then the method of estimation of these impurities. And then thirdly, various refinery flow sheet and uh, production of different uh, kind of fuels from petroleum as it is found in the form of crude oil. It is used for the production of various liquid fuels. So different techniques for the production of liquid fuel, then various conversion methods, the conversion of one kind of fuel to another, depending on the requirement of the market and its techniques such as thermal and fluid catalytic cracking, hydrocracking, reforming, isomerization, alkylization, polymerization, and blending. So let us start with the what is petroleum. So basically, petroleum is also another kind of uh, uh, fuel. The word which comes from petra and oleum, and petra is derived is meaning rock, and oleum means oil. So basically, it is rock oil. It is basically a mixture of organic compounds which are found within the earth, and it also mainly consists of hydrogen, carbon, and oxygen. Just a second, somebody wants to join. Okay, I guess. Okay. So if the main constituents of petroleum is hydrogen, carbon, and oxygen. So crude oil, uh, basically crude oil, what it is? It is a complex mixture of hydrocarbons. Basically, it can consist of paraffins, naphthalene, and aromatics. It is brownish black in color and colloidal in nature. So what is the difference between crude oil and petroleum? They are basically same. Crude oil and petroleum is basically same, but petroleum, it is a broad category which consists of both crude oil and some petroleum products. The elemental composition of crude oil consists of mainly carbon, which is 83 to 87%, hydrogen 10 to 14%, which was much lesser in the case of coal, that is up to 5.5%, nitrogen 0.1 to 2%, oxygen 0.1 to 1.5%, sulfur 0.5 to 6%, and some amount of metal that too in a very small amount. Coming on to origin of petroleum. Petroleum origin consists of two different types of theories. First one is inorganic theory and the second one is organic theory. The inorganic theory says that hydrogen and carbon, which is present under the earth, it comes together under great temperature and pressure below the earth's surface and forms oil and gases after chemical reactions have occurred between them. But the second theory, that is organic theory, it says that as coal is produced from the plant remains, here petroleum is found to have been formed from the animal remains. It says that the saturated oil, absence of oxygen, and high pressure and temperature, when uh, All these conditions contribute to the decay of organic matters, that is mainly the animal matters, which is then transformed into kerogen, forming a source rock. Basically, it says that the coal, it is believed that coal is formed from the remains of plants, but petroleum is believed to have been formed from the remains of dead sea animals under the action of high temperature and pressure down below the Earth's surface. Coming on to the availability of petroleum and energy production from it. Total world oil reserve consists of 30% of oil sand bitumen, 30% conventional oil, 15% heavy oil, and 25% extra heavy oil. And the world oil reserve on the basis of region, which shows that the largest oil reserves are found in the Middle East, that is 49%. In Eurasia region, it is 7%. Europe region, it is 1%. Central and South America, it is 20%. North America, 13%. Asia and Oceania, 3%. Africa, 8%. Basically, in India, there are not much oil reserves found. There are found, but very less. Coming on to different types and grades of petroleum. They are basically divided into three grades: light crude oil, medium crude oil, and heavy crude oil, depending on its API gravity. API gravity is basically telling us about the specific gravity of the crude oil. So highest, the as high as the API gravity, the quality of crude oil is found to be good. So the highest API gravity, having highest API gravity more than 31.1 API, are the light crude, and the crude oil having API gravity less than 22.3 API, it is the heaviest crude, and crude having API between 22.3 and 31.1 is the medium crude oil. Although over 160 different oils are traded on the market, they are basically three primary distribution, but there are still various other kinds of crude oils also found in the market. Some other kind of some other important crude oils are the West Texas Intermediate and extremely high quality crude oil. It is a very high quality crude oil which has a API gravity, very larger API gravity, that is 39.66, but and sulfur content is also very low, that is 0.24%. Brent Brent blend, combination of different oils from 15 fields throughout the Scottish Brent and Ninian systems located in the North Sea. It has API 38.3, but the sulfur content is more than the West Texas Intermediate. And the third type is the OPEC reference basket, collective of 11 different crude oils from Algeria, Iraq, Kuwait, Libya, Qatar, Iran, Saudi Arabia, Indonesia, Nigeria, Venezuela, and UAE. It is also having a good API of 32.7 degrees, but the sulfur content here is very high, that is 1.77%. Coming on to the various petroleum products and its classification and energy content. So what we do is what we get the crude oil, and we do the distillation. Fractional distillation of crude oil is done in the reactor containing different plate arrangement. So what we get is we get different kind of products. It when Mm. Crude oil is taken, and it is and fractional distillation is done, which gives different kind of products consisting of C1 to C4, that is the lightest product, that is in the form of gases, that is LPG. From C5 to C9, that is naphtha. It is used for in various. It is used as different as chemicals in different processes. Then C5 to C10, which is gasoline used in various vehicles. C10 to C16, that is kerosene used in various jet fuels, paraffins for lighting and heating. C14 to C20, that is the diesel oil. In various diesel fuels it is used. So the distribution of these, the extraction of these fuels is done, of these different types of products is done on the basis of their boiling point. So C4 to C20, that is diesel oil used in various diesel fuels. Then C20 to C50, that is the lubricating oil. So as we come down, these are the lighter products and these are the heavier products. So the as the C content, as the carbon content increase, it's uh, they become heavier and consist of and impurities in them also increases. That is the lubricating oil used as lubes, waxes, and polishes. C20 to C70, that as fuel oil, it is used in various industries. And greater than 70, that is the residue. Mainly, it is bitumen, etc., used for the roofs and roofing and road and in the manufacturing of roads, etc. Coming on to petroleum products and its classification. So these primary petroleum products consist of gasoline used in automobiles, light trucks, small engine fuel, then the diesel used in automobiles, heavy trucks, heavy equipment, jet fuel in commercial and military aircrafts. So the energy content of them is LPG shows a heating value of 46.1 megajoule per kg. The gasoline 46.5 megajoule per kg, kerosene 46.2 megajoule per kg, and diesel 45.8 megajoule per kg, and residue, that is 42.2 megajoule per kg. As the product becomes heavier, impurity in them increase as well as their heating content also decreases. Secondary products, there are various other secondary products which are produced, that is the kerosene, LPG, fuel oil, asphalt, like carbon black oil, lubricating oil, waxes, petroleum coke, sulfur, NaHs, and they are used in various different applications. They are used in various different applications. Coming on to the composition of crude oil, crude oil consists of both hydrocarbon as well as non-hydrocarbon part. Hydrocarbon part consists mainly of aliphatics, uh, aromatics, and naphthalene. Aliphatics almost 25%, aromatics 17%, and the largest is the naphthalene, that is 50%. And in non-hydrocarbon part, they consist of sulfur, nitrogen, oxygen, and metals. Thus, some metals are also found, but in very less quantity. So main constituents of crude oil, it is basically carbon and hydrogen, and LPG, such as the lightest product, that is LPG. It is mainly paraffin C1 to C4, then gasoline, paraffins, aromatics, and naphthalene are found C5 to C10, kerosene in also all three paraffins, aromatics, and naphthalene, that is C11 to C18. Gas oil, it is C18 to C28. VGO, it is C28 to C14. In residue, which is the heaviest product, that is asphaltic, mainly used in roads and roofing, that is above C40 content. Coming on to crude oil pricing, as we have seen in the coal as we saw in coal, that uh, as the moisture content increased, its quality decreases and pricing also decrease. Therefore, in case of crude oil, here petroleum, it is judged on the basis of sulfur content and its gravity. As I have told, that as the crude oil with the highest API gravity is of the finest quality, so the crude oil with the higher API gravity will be having more pricing. And as we know, sulfur is an impurity. So as if the sulfur content is lower, then the crude oil is finer in quality. So here we can see, as the sulfur content is decreasing and API is increasing, the crude oil pricing is also increasing. Petroleum for energy production, some issues related to petroleum energy production. So oil-based economy and carbon credits. So As we have seen in in coal also, while production of energy from coal, there is huge amount of carbon emission found in the atmosphere. The same problem goes with the energy production in petroleum. So that needs to be taken care of. Depletion of high quality crude oil. As the time is passing by, higher quality crude oil is depleting day by day. Okay? Sustainability issues, and the third thing is that the sustainability issues in the 21st century, as we have seen, the main issue is the carbon emission and problems, and the sustainability issue which needs to be kept into mind while doing the energy production from various crude oil. There is this CO2 reduction target, which is the Kyoto environmental initiative, such as Kyoto, in which this is the limit which needs to this is the current baseline, and we need to decrease the carbon content in respect to this baseline. So till 2010, it was estimated to decrease the carbon content by 10%, and till 2020, it is estimated to decrease by 20%. So the trend towards processing of heavier crude, so we have to follow this Kyoto environmental initiative. If that means that while doing energy production from petroleum, and the carbon emission needs to be decreased. This is the main problem which needs to be taken care while doing the energy production from petroleum. These are some of the basic properties of petroleum, such as coming on to properties of petroleum, that is the density and API, read vapor pressure, pour point, viscosity, wax content, asphaltenes, carbon residue, ash content, distillation characteristics, phase of crude oil, carbon and hydrogen ratio. Or some other important properties are octane number, cetane number, diesel index, smoke point, heating value, flash point. All these things we will be studying further. And these are some of the impurities which are found in the petroleum crude oil, that is water content, salt content, BSNW, that is basic, sediment and water, sulfur content, nitrogen content, inorganic and total acid, and trace metals. All this we will be studying further. Coming on to the first one, that is density. It is basically used to the density, as we all know, that is mass upon volume. The specific gravity is the density with respect to the density of water. So the API here is used, it is the weight to volume or vice versa calculation for checking the consistency of food supply. So API is given by the formula 141.5 upon specific gravity at 60 degree Fahrenheit of the crude oil minus 131.5. So as I have told, the crude oil, the product with the higher API gravity is said to be the crude oil is said to be the product of the finer quality. So as the API gravity increases, its quality is said to increase. So as we can see here, example, water has 10 API, kerosene 45 API, motor gasoline 58 API, and natural gasoline 75 API. So here we can say that natural gasoline is of finer quality as it has higher API than all of them. Read vapor pressure and light and composition. Read vapor pressure is basically the percentage of gaseous and liquid hydrocarbon in crude oil. Is uh, it is defined as the absolute vapor pressure exerted by a liquid at 37.8 degrees C, as determined by this is the standard method for the testing of read vapor pressure, that is ASTM D323, which was first developed in 1930. The light and analysis carried out by GLC actually gives the percentage of hydrocarbon up to C5 and is the basis of assessing the LPG potential. It is basically the lower carbon compound, that is C1 to C5, comes under LPG, So if the vapor pressure is higher, that means the product with the lesser carbon compound will be having higher vapor pressure. So the component with the higher vapor pressure, we can tell that if it is of better quality LPG or not. 4 point in wax content. 4 point, it is basically the temperature below which the crude oil ceases to flow. It is a temperature below which pumping and transportation problem may be encountered. Indicates relative amount of wax percentage. If more wax percentage will be there, then the flow will be ceased at a higher temperature. Along with viscosity. So it is basically used for the determination while determining the pumping and designing calculation. 4 point plays a very crucial role. Wax content is basically the normal paraffins above C16 are solids at somewhat ambient temperature. These hydrocarbons affect the flow behavior of crude product, quality of gas oil, vacuum gas oil, and asphalt. Fuel manufacture is also dependent on wax content of the crude, and it is calculated using the Anglais-Holday method, which is 2 part of absolute alcohol and 1 part of absolute ether is used as the solvent. By using the mixture of 2 part of alcohol and 1 part of ether and mixing them with the crude oil, the paraffin wax can be precipitated on cooling it to -20 degrees. Asphaltenes, carbon residue, and ash content. Asphaltenes are polynuclear condensed aromatic hydrocarbon having high molecular weight. So basically, these are the higher molecular weight component found in the crude oil. These are insoluble in heptane and soluble in benzene and toluene. Asphaltene and carbon residue indicate the extent to which heavy hydrocarbons are present in crude oil. So it is basically the heavier content. If more heavier hydrocarbons are present, so asphaltenes and carbon content will be more. Carbonaceous residues found after evaporation. If we do the pyrolysis of a crude oil sample, then the residue found, it is in the form of a coke, which gives the carbon content, and it is calculated by the Conradson carbon residue method. Ash content, it is the metallic constituents concentrate in the ash of the crude. Ash content is found here also, as we saw uh, in the coal samples. So determination of ash content and carbon residue. As I told here that it is determined using Conradson carbon residue method. So here it is. Ash content here also is determined using the proximate analysis, which is given by the formula. It can also be found on the dry basis as well as wet basis. So in Conradson carbon residue method, a quantity of sample is weighed. It is placed in the crucible and subjected to destructive distillation. During a fixed period, for a fixed period, severe heating is done. The sample undergoes cracking and coking reaction. After the termination of the heating period, the crucible contain the carbonaceous residue, which is cooled in a desiccator and weighed, and this weight residue is found to be the residue remaining is calculated and it is calculated in the percentage of the original sample and reported as Conradson carbon residue. Coming on to the salt content, our crude oil consists of various salts also, mainly chlorides and sulfates of sodium, potassium, calcium, and magnesium are found. They can be present in the form of crystalline. They can be present in the crystalline state or may be suspended, it's solid or dissolved into the water present in the crude oil. So, the various problems that occur due to the presence of these salt content is the irregular behavior in distillation, equipment corrosion during atmospheric distillation due to HCl formation, blocking and fouling of heat exchanger can take place, residual product contamination can also take place. So salt availability can take place in two forms. Either it can be present in the crystalline state or it can be present in the dissolved state in water present in the crude oil. So, salts may vary in ratio of metal ions. It can different amount in which salts may be present. That is sodium 70 to 75%, magnesium 15 to 20%, and calcium 10%. So magnesium is most prolific, is the most producer of HCl, with calcium and sodium in descending order. So smaller quantity of HCl substantially enhance. Even if the smallest quantity of HCl is present, then corrosion can take place. So this is a brine droplet, that is basically a salt dissolved in water. And these are this is in the form of emulsion in oil, surrounded by resin, carboxylates, waxy agglomerates, asphaltenes, naphthenides, and alkyne benzene, which also co-stabilizes this brine droplet. Determination of salt is done in different ways. That is, the first one is IP 77 by 72 method, that is extraction with water, that is the titration method. And the second one is ASTM D3230, that is the conductivity measurement based on the calibration with sodium, calcium, and magnesium chlorides. Some metals are also found in the crude oil. That is, main metals in crude oils are basically lead, nickel, vanadium, and copper. They are present in very small amount, that is in ppm level, and they are in even in ppm level they are poisonous to catalyst, to various catalysts used in uh, in different extraction methods. Sediments in water. Sediments are different from salt. uh, Sediments, they are basically fine particles of sand, clay, volcanic ash, drilling must, rust iron sulfide, metals, and scales. The damaging effect done by them is plugging, abrasion, and residual product contamination. Water causes irregular behavior and distillation. So, sediment in crude oil is removed by these methods, that is BSNW, ASTM D96 method, ASTM D4007, Dean and Stark, and ASTM D4006. So, some other impurities found in crude oil, basically, they are the sulfur, nitrogen, and oxygen. Sulfur, mainly impurities are present in elemental form. Sulfur can be present in both elemental form or in oxides and sulfides form. So, oxides such as hydrogen sulfide, then mercaptans in LPG. Sweet, the processes to remove sulfur is the sweetening process, that is caustic washing can be done. Mercaptan oxidation are used to remove these impurities from products. Nitrogen is present in either elemental form or as oxides of nitrogen. Forms acids and Nitrogen forms acid and can cause corrosion. Removal is necessary to get on grade products and secondary units feedstock. Oxygen, that is present in either in elemental form or as compounds of oxygen from naphthenic acids, and also can cause corrosion. Now coming on to another property, that is octane number. It is basically a value to indicate the resistance of a motor fuel to knock. So it is also called the octane rating. What it is basically done? It is measured on a scale on which isooctane is taken as 100, as isooctane shows minimal knocking against a motor fuel, and heptane as 0, which is showing a very bad knock. So the higher the octane number, the more compression is required for fuel ignition. It may be determined as it can be determined using the method of research octane number and motor octane number. And what we do is, research octane number is determined by running a fuel in a test engine and with a variable compression ratio under controlled condition, and comparing the result with those for uh, 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 mixture of isooctane and heptane. And motor octane number is calculated by following the same procedure, but the motor octane number is determined at 900 rpm engine speed, whereas the research octane number is determined at 600 rpm. So, and also the anti-knock index can also be calculated by the formula research octane number plus motor octane number by 2. Coming on to cetane number, octane number is the property of petrol, whereas the cetane number is the property of diesel. So it is relative measure of the interval between the beginning of injection and auto ignition of fuel. The higher the cetane number, the shorter the delay between the injection and the auto ignition of the fuel. Cetane number is calculated by a mixture of cetane, uh, which gives a hundred value, and one methyl naphthalene, which is zero value. So cetane number is measured by burning the fuel in a cooperative fuel research engine under standard test conditions. A hand wheel is used to increase the compression ratio of the engine until the time between fuel injection and ignition is 2.407 milliseconds. So the resulting cetane number is then calculated uh, by taking a mixture of cetane and one methyl naphthalene in, and by following the same procedure when the time between the fuel injection and ignition is 2.47, and then that would be the result, that would be the cetane number of this fuel. The third quality is the aniline point and diesel index. So aniline point of an oil is determined by it is the property of lube oils basically. So the aniline point is calculated. It is basically the minimum temperature at which equal amount of aniline and lubricant oil are miscible to form a single phase upon mixing. So this is the formula for diesel index, that is aniline point into API by 100. And the acid value is that industry standards for measuring the acid content of a crude oil is the total acid number, that is TAN. That is calculated by the formula milligram of potassium hydroxide, which is required to neutralize all free acids per gram of crude oil. So crude oil with total acid numbers higher than 1.0 are called the high TAN crudes, and the likewise total base number can also be calculated paid by the amount of perchloric acid required to neutralize all the bases in per gram of crude oil. Coming on to the viscosity. So viscosity refers to the thickness of the oil, and it is determined by measuring the amount of time taken for a given measure of oil to pass through orifice of a specified size. So it is given by the when liquid flows through a tube, it is given by the Poiseuille's equation, which is uh, eta equals to pi r to the power 4 Pt by HBl, where eta is the viscosity coefficient, T is the time of the flow of liquid, and V is the volume of the liquid, P is the hydrostatic pressure, L is the distance traveled by the liquid during the time T, and R is the radius of the tube, and Mr is the mass of the reference liquid. So here we can say that R, R is the radius of the tube, which is fixed, volume of the liquid, which is also fixed, and distance traveled by the liquid during the time t is also fixed. So, taking this value as constant, which is K, and P is the pressure, that is the hydrostatic pressure given by mgh. For mass therefore P is proportional to mass, and T is the time. So, if we take this equation, eta is proportional to kmt, K is that is constant. So we can use this for the proportion. We can say this, that eta is directly proportional to mass and time. And mass and time of flow. Viscosity can be measured using different viscometers such as Ostwald viscometer, falling sphere viscometer, falling piston viscometer, oscillating piston viscometer, vibrational viscometer, rotational viscometer, and bubbles viscometer. Another property is flash point. The flash point temperature of a fuel is the minimum temperature if a fuel is ignited. If the fuel is ignited, if the flash mean if we when a if we heat a fuel, the vapors are generated, and if we bring a matchstick in contact to it, the minimum temperature at which the matchstick starts to lighten up, that is the flash point. And if we further increase the temperature, then when this and vapor increases, and this flash catches fire, that is the fire point. There are basically two types of flash point measurement, that is open cup and closed cup. In open cup, flash point varies with the height of the flame above the liquid surface, and at sufficient height, if the measured flash point coincides with the fire point. But in closed cup, the cups are sealed with lid through which the ignition source can be introduced. And the closed cup tester gives lower value for the flash point than the open cup value, at least 5 to 10% lower than the open cup. Asphalt properties. As I told you that the asphalt products are basically the heavy hydrocarbon products that are derived from the crude oil. So they are basically of type straight run, that is straight off the vacuum distillation unit, or by removing some of the that propane deasphaltane, that is by removing some amount of propane cut, that is the straight cut back by using dilutants to improve the flowability of the asphalt product, that is three types of solvent, three types of just three types of cutback products by using dilutant, that is different type of solvents. By mixing different types of solvent in the asphalt products, we improve the flowing property of the asphalt, that is the rapid cure or medium cure and slow cure, that is naphtha dilute by mixing of naphtha, and the medium cure by mixing of kerosene, and the slow cure by mixing of gas oil. Emulsion asphalt, that is by mixing of 30 to 50% of water in the asphalt product, emulsion is made, and not only water but some kind of emulsifying agents for the stabilization of the emulsion. And the third one is industrial or blown asphalt. That is when and that is air is blown into the asphalt, and made by blowing air through the hot asphalt, causing asphaltenes to combine. So this kind of asphalt is mainly used in roofing and waterproofing materials. Two main techniques for the two main properties of asphalt is the softening point, that is the lowest temperature at which a standard weight or shape will sink into the asphalt. And the hardness is the depth to which a test needle sinks into the asphalt over time at specified temperature. Coming on to the uh, crude oil refining. This is the overall flow sheet of the which is employed in the crude oil refining. So basically, firstly, what is done, desalting is done, in which different kind of salts present in the crude oil are removed. Then this, uh, uh, after desalting, the crude oil is preheated, and it is sent to the atmospheric distillation unit, where distillation after distillation different products are released, that is the lighter product in the form of gases is released from upper side. Then the different cuts of products are removed here, the naphtha, kerosene, gas oil, depending on their boiling point, are released, and the heavy residue is taken to the vacuum distillation unit, where again distillation takes place and different lube oil fractions depending on their boiling point is released. And further, the heavier part is taken for further processing, which mainly gives the lube oils, bitumens, syngas, and fuel oil. And further, another thing is the conversion of intermediates, conversion of these products to different, suppose gasoline to diesel or gasoline to kerosene takes place, which is done to improve the quality and yield, and also depending on the market requirement. So, firstly, coming on to, as we have seen, the first step is desalting. So, firstly, coming on to desalting. So the purpose of desalting is the removal of undesirable impurities, especially salts. As I have told that crude oil consists of different kind of salts of magnesium, calcium, sodium. So all these needs to be removed. Otherwise, they causes problem in further distillation. As such as I have told, they cause scaling in heat exchanger and further poisoning of catalyst, etc. So the Desalting can be done either in a one-step or two-step procedure. It is the removal of undesirable impurities, especially salts and water from the crude oil prior to distillation. Initially, sometimes initially at the point of production of crude oil, some amount of desalting is done there also. Then after transportation of crude oil to the refinery before atmospheric distillation, also some amount of desalting is done. For refining purpose, a salt concentration of maximum 1.5 ppb, that is pound of salt as NaCl per 1000 barrel, is desired. Appreciable amount of suspended solids can be removed by desalting. The total solid concentration and formation water range. Uh, so mainly what we do in desalting is that in desalting what is done, that salt is dissolved in water and removed in the form of brine. Important variables affecting the desalting performance is the settling time. When we add water to for the dissolution of this salt in water, so this water in crude oil forms an emulsion, and these emulsion droplets settle down. So this settling time of these droplets also affects the desalting performance. Then the demulsifier injection, some emulsifying agents are required for the stability of the emulsion. Then the amount of temperature we give, the addition of fresh water, then effective mixture of oil and water as well as chemicals for breaking the emulsion, and electricity. So what the gravitational residence time is based. The residence time, that is the settling time, is based on Stokes equation, which is given by nu equals to 2r square delta rho g by 9 eta, which is nu is the downward velocity of the water droplets, the settling velocity of water droplet of radius r. This is the radius of the water droplet. This is the density difference of the two phases, that is the water and the oil. And this is the eta is the viscosity of the oil phase. So maximizing the size of policed water drop. So, so there are just a second. Okay. Then coming on to the desalting procedure, there are two types. Desalting is done in two ways. The first one is electrostat. The first one is firstly what we from here crude oil is taken, and from here fresh water is induced. As I told that the salts are removed from the crude oil by mixing of fresh water into the crude oil, and this fresh water dissolve the various salts, and salts are removed in the form of brine. And these are the demulsifying agents. As we add water, emulsion will be formed. So for the stabilization of emulsion, and some demulsifier agents are also used. So here we introduce freshwater demulsifier agents, crude oil, and mixing is done by the mixing valve, and then electrostatic separator. And this mixture enters into the electrostatic separator, and from here we get the effluent water and the desalted crude oil. But here, in the second one, process water is taken here, and unrefined crude is taken here, and the crude is heated. Uh, Sometimes what happen is all the salts are not dissolved in the water. So sometimes heat we provide some amount of heat for the dissolution of these salts in water. So here crude oil is heated prior to entry in the reactor, and here mixing takes place, and here by the gravity settler, the droplets of brine settle down, and here we take out the effluent water with salt, and this is the desalted crude. Then this desalted crude is introduced into the atmospheric distillation unit, where distillation takes place, and different products, depending on their boiling point difference, different products are given out at different cuts. So atmospheric distillation is typically performed in large vertical steel cylindrical columns with diameter ranging from 65 centimeter to 11 meter and height ranging from 6 meter to 60 meter or more. So pressure here is bubble pressure based on coolant temperature, and pressure drop in condenser is 0.3 to 0.5 kg per centimeter square, and tray pressure drop is 0.08 to 0.1 kg per centimeter square. The temperature is 8 to 10 degrees C above the water dew point. Flash zone below cracking temperature is 350 to 385 degrees C. And typically 40 to 50 actual trays are taken and pump around between 2 to 3 trays. So what happens is we introduce steam from here, and crude is introduced here, desalted crude is introduced here, and here distillation takes place, and the lightest product is given out from the upper part, and various other products are given from the side cuts depending on their boiling point, such as here kerosene is given, LGO, that is light gas oil, and heavy gas oil, and this is the residue given from below, which is further processed again in the vacuum distillation unit. Coming to the vacuum distillation column, normally has 10 to 40, and this distillation is done in vacuum that is 10 to 40 mmHg absolute pressure, which increases the volume of vapor formed per volume of liquid distilled. Such columns have very large diameters, 15 meters or more, and heights ranging about 50 meters. Most of the column uses packing materials. As we have seen in the distillation unit here, distillation column is there, but here packing packed bed distillation column is here for the vapor liquid contacting, because such packing has a lower pressure drop than the distillation phase. A very low pressure a very low pressure increase from the top of the column, top to the bottom, is maintained. So here we have from here crude is taken with the process steam, and the distillation takes place, and the lightest and the crudes are and different crudes depending on their boiling points are released, that is LVGO, that is uh, light vap- uh, uh, light vacuum gas oil, heavy vacuum gas oil, wash oil, and vacuum residue, which is further taken for further processing. Various products in atmospheric distillation unit is LPG, light naphtha, heavy naphtha, aviation turbine fuel, kerosene, light gas oil, heavy gas oil, and atmospheric residue, which is taken to the vacuum distillation unit for further treatment. And vacuum distillation unit gives two types of products. First is fuel based, and the second one is lube based. Fuel based is diesel, light vacuum gas oil, heavy vacuum gas oil, slop distillate, and vacuum residue. And the lube based is the spindle oil, light neutral, intermediate neutral, heavy neutral, vacuum residue. The need for the third portion, the next portion is the need of conversion of these intermediate products. So these intermediate products are interconverted, such as the diesel may be converted to kerosene, or light naphtha to heavy naphtha. So all these conversions are also done to improve. The reason for them is to improve the product quality. Then the second one is to meet the market requirement of different products, and the third one is to achieve the environmental standards. So there are various techniques for the conversion of these intermediate products. The first one is thermal and catalytic cracking. So cracking basically is the word itself says that the cracking is the cracking of heavy hydrocarbons to lighter hydrocarbons. That is and it is done in two ways. That is, the first one is thermal cracking, and the second one is catalytic cracking. Thermal cracking takes place in the presence of heat, whereas catalytic cracking takes place in the presence of catalyst. So during the cracking, large molecules decompose and form smaller molecules under high temperature. That is, in thermal cracking, temperature range is 500 to 700 and pressure is 70 atmosphere pressure. And the catalytic cracking takes place in the presence of catalyst under mild temperature, that is 475 to 530 and pressure of 20 atmosphere. So for both cases, types of reaction takes place. That is primary reaction in which decomposition of large molecules to smaller molecules takes place, and secondary reaction by which active products from primary cracking further crack or react to form other products. Thermal cracking reactions takes place through free radical mechanism, whereas catalytic cracking reactions takes place through carbocation formation, that is either carbonium or carbanium ion formation. FCC is an important uh, fluidized catalytic cracking unit. In this, the feed in fluidized catalytic cracking is vacuum gas oil, hydrotreated vacuum gas oil, hydrocracker bottom, coker gas oil, deasphalted oil, reduced crude oil, and the vacuum residue. So what happens is we take the feed from here, the product which we need to crack. We take the feed along with the catalyst is taken here in the from the riser. It goes up and the reaction takes place here. And the after the cracking, the product goes out from here, and the catalyst again goes back to the regenerator for regeneration. That is, the catalyst after deactivation goes here, and after the reactivation, it comes back to the feed for further usage. So the different products given out are dry gas, LPG, light cracked naphtha, heavy cracked naphtha, light cycle oil, clarified oil, or decant oil. The next technique is the hydrocracking. That is the various hydrocracking. It is basically the cracking of heavier hydrocarbon and further addition of hydrogen to it. It mitigates the coke formation during cracking of higher molecular weight polar constituents. It also helps to remove heteroatoms. So the feed in hydrocracking is straight run gas oil, vacuum gas oil, cycle oil, coker gas oil, thermally cracked stock, solvent deasphalted residual oil, straight run naphthas, cracked naphtha. The product produced are LPG, motor gas oil, reformer feeds, ATF, diesel fuels, heating oils, solvent and thinners, lube oils, petrochemical feedstocks. So hydrocracking is done in two hydrocracking catalysts. Various catalysts are used during hydrocracking reaction. Catalysts are dual function. The first function which catalysts are used for is the cracking, that is isomerization cracking, and the third one is hydrogenation. So firstly cracking takes place, and secondly the addition or subtraction of, that is hydrogenation or dehydrogenation of the hydrocarbon takes place. So cracking function is provided by acidic support such as amorphous oxides, for example silica. These are the catalysts, silica alumina or crystalline zeolite, that is modified zeolite along with binder, or a mixture of crystalline zeolite or amorphous oxides. And the second procedure is hydrogenation or dehydrogenation, which is done in the presence of metals. So noble metals such as platinum or palladium, and non-noble metal sulfides such as molybdenum or tin. Tin group and nickel and cobalt is used. So as noble metals are expensive, so we are wishing to replace these noble metals from non-noble metals, but still non-noble metal catalysts are still very less. The reactions occurring and products formed depends critically upon the relative strength of the two components. Typical two-stage process flow scheme is: here we take the makeup hydrogen, that is in hydrocracking, hydrogen is added and fresh feed is added. And this on preheating is done here, and after preheating it is taken to the first reactor where hydrocracking takes place. After hydrocracking, further heat recovery. After heat recovery, it is sent to the high pressure separator where separation takes place, and further the gas is sent to the further the gas is sent to the low pressure flash drum, and after flashing here pressure release, it is sent to the debutanizer. From here butane, that is C4 recovery takes place, and further it is sent to the fractionator, that is after distillation. Here different cuts are removed, that is light naphtha, heavy naphtha, kerosene, gas oil, and the heavy residue from here is taken here along with the makeup hydrogen. It is further heated. After preheating, it is sent to the second reactor, and here again after the heat recovery and high pressure separator, uh, it sends back the heavier part to the again low pressure flash drum, and the lighter part is taken for recycling. Another technique is reforming and isomerization. Reforming it helps to produce high it reforming helps to produce high octane number reformate. Main component is motor fuel, aviation gasoline blending for aromatic rich feedstock as well as hydrogen rich gas. The feedstock in this is either low quality straight run naphtha or cracked naphtha, generally mixed with straight run naphtha. Reactions taking place is naphthalene dehydrogenation occurs, paraffin dehydrocyclization, and linear paraffin isomerization, naphthenes isomerization. And the other technique is the isomerization, in which the isomerization is basically the reformation of the that is the as we know that isomers are basically the compounds with the same formula but different structure. So the reformation in the structure takes place, is thus giving the isomers of the same product to produce branched C5 to C5 C6 hydrocarbon premium gasoline production, reduction of benzene, aromatics and olefins, and LPG production. So this is basically done for when we need high octane components in gasoline. Then blending, refining products are blended for the optimal use of all the intermediate products streams for the most efficient and profitable conversion of petroleum to the market desired products. So, few examples are typical motor gasoline may consist of straight run naphtha from distillation, crackate from SPC, reformate, alkylate, isomerate, and polymerate in proportion to make the desirable grades of when we need when the due to the market requirement, different market requirements, different products, different petroleum products are blended together to give the desired output that is required. So in most cases, the components blended non-linearly for a given property, for example, vapor pressure, octane number, cetane number, etc. Then the polymerization is an alkylation. In polymerization, light olefins are induced to combine and polymerize into molecules of two or more times its original molecular weight. So the catalyst employed consists of phosphoric acid on pellets of Kieselguhr, which require high pressure in the order of 30 to 75 bar at a temperature of 175 to 230 degrees C. Polymer gasolines derived from propylene and butylene have their very high octane number, that is above 90. The alkylation reactions also achieve a longer chain molecule by the combination of two smaller molecules, one being an olefin, the other being isoparaffin. And the catalyst used here are sulfuric acid and hydrofluoric acid. In sulfuric acid alkylation, concentrated sulfuric acid of 98% purity serves as the catalyst for a reaction that is carried out at 2 to 7 degrees C, and the octane number obtained is 85 to 95. So we are done with the theory. So let us come to the question answer part, assignment part basically. So let us start with the questions. The first question is, match the petroleum products with their applications. Anyone? Am I audible? Am I audible to you all? Am I audible? Anyone please answer? Hello. Okay. So let me start with the question answer part. And I would like you guys to answer at least objective questions you can answer. Match the petroleum products with their applications. Anyone from the student side? Okay, the answer to this I will be telling. So waxes are basically used in the candles and industrial sealants, the third one, P to the third one. And petroleum coke is used in coal-fired boilers, on asphalts used in roads and roofing materials. So the answer to this is P3, Q2, and R1. Just a second. Okay, sorry, Q1. It is right. So P3, Q1, and R2. Okay. Which of the following can be a non-hydrocarbon constituent present in crude oil? Anyone? So the answer to this is, as we can see, hydrocarbon. Aliphatic compounds are also hydrocarbons. Aromatic compounds are also hydrocarbons. Naphthalene are also hydrocarbons. So the remaining one is sulfur. So sulfur is the constituent which is present in crude oil and it is not an hydrocarbon. Coming to the third question, which is 4 point indicates the relative amount of the dash content in crude oil. Anyone? The answer to this is wax, as I told that the 4 point tells about it is the minimum temperature at which the crude oil ceases to flow. So if wax content is present, it will cease to flow faster. The fourth question, which is the find the appropriate expression used to compute electrostatic attraction between water droplets in crude oil. Here, what is electrostatic force between two adjacent droplets? E is the voltage gradient, K is the dielectric constant, D is the diameter of water droplets, S is the center to center distance between two adjacent droplets. So the answer to this is F equals to A to the power K E square D to the power 6 upon S to the power 4. So the second answer is correct. Sorry, second option is correct. Coming on to the fifth question, which is match the following products with their API gravity. As in the theory class, theory part, I told water has a API gravity of 10. Kerosene, I guess, has 45 and natural gas 75. So, yes, the answer is water 10, kerosene is 45, and natural gas is 75. Which of the factors affects the performance of fluidized catalytic cracking? Select the most suitable answer. The answer to this is all of the above, as feed rate also affects the catalytic cracking performance, the cycle ratio, and reactor pressure also affects the performance of FCC. The seventh question. In petroleum refineries, sweetening processes are primarily used to remove, as I told, it is used for the removal of sulfur content. Eighth question. Which of the following is not an important method used for sulfur detection? In the sulfur detection, calorimetric method is also important. Big bond method is also used, and X-ray fluorescence is also used. So the remaining one is Fourier transform infrared spectroscopy, which is FTIR, and it is used for the determination of various functional groups available in a sample. So it is not an important characterization technique for sulfur detection. Coming on to the question number 9, which is a small numerical. The question is the API gravity of natural gasoline and kerosene are 60 and 50 respectively. So the API gravity is given. Determine the difference in their specific gravity. So you guys try it. Okay, let me start with this question. So formula for API gravity is API equals to 141.5 upon specific gravity at 60 degrees Fahrenheit minus 131.5. So specific gravity will be 141.5 upon 131.5 plus API. So for 60-degree API, specific gravity will be 141.5 upon 131.5 plus 60, which is 141.5 upon 191.5, giving us 0.7389. For 50-degree API, specific gravity would be 141.5 upon 131.5 plus 50, which will give 141.5 upon 181.5, giving us 0.7796. So the difference of specific gravity would be 0.7796 minus 0.7389, giving us an approximate value of 0.041. Answer to this is 0.041. Is this clear to you? Okay, then coming on to the next question, which is the same amount of aniline and a lube sample is heated under specified conditions and these mixed at 115 degrees C. With the specific gravity of the lube oil is 0.75, determine the diesel index of the oil. So what is given here? We have to calculate the diesel index whose formula is aniline point into API gravity upon 100. So what is the aniline point? The value of aniline point here, the aniline point is basically the same amount of the temperature at which the same amount of aniline and a lube sample is miscible. So here aniline point is given where 115 as at 115 degrees C same amount of aniline and lube sample is miscible. So aniline point is given 115 degrees C. We want it in Fahrenheit as in the formula it is aniline point in Fahrenheit. So it is, we have to convert it to Fahrenheit into 9 by 5 plus 32, which will give us 239 degree Fahrenheit. So this is the aniline point in degree Fahrenheit. API gravity we have to calculate as specific gravity is given. So it is 141 upon specific gravity, that is 0.75 minus 131.5. So it is 57.16 degree API. The diesel index formula is aniline point in degree Fahrenheit into API gravity upon 100. So it will be 239 into 57.16 divided by 100, which will give us 136.612. So the answer is 136.61. Is this clear to you all? Coming on to the next question, what is the typical carbon percentage in crude oil? The answer is 83 to 87 percentage of carbon content is present in crude oil. What is the API gravity of medium oil? It is between 22.3 to 31.1 API gravity. What are the influencing factors for crude oil pricing? So it is basically all of these, as crude oil pricing depends on all three: supply, demand, and political economic development in the countries, consuming countries, and weather conditions. Now coming on to one other numerical, which is the API gravity of West Texas Intermediate crude oil is 41.6. So API gravity is given 41.6. So what will be the volume of 1 metric ton of this crude oil in barrel units? And the hint is given, one barrel is 155 equals to 159 liters. So let us start with this question. So let us first calculate the specific gravity, as API gravity is given. So it is 141.5 upon 131.5 plus 41.6, which is 0.81744. So it is volume of 1 kg oil. By the specific gravity we can calculate, as the specific gravity is given above. So it is basically the uh, density. So mass upon volume. So if mass is here and density equals to mass upon volumes, so volume will be mass upon density. So mass is 1 kg. So taking as we want volume of 1 kg oil, so taking mass as 1 kg, and density is 0.81744. We get the volume as 1.2233 liters. So volume of 1 metric ton of crude oil. So 1 ton equals to 1000 kg. So it is multiplied by 1000. So we get it in liters. And as we have given here, 1 barrel equals to 159 liters. So dividing it by 159, we will get as 7.69 barrel of oil, which is almost 7.70 barrels. So is this clear to you all? Okay, then let us come to the next question, which is during desalting process after coalescence, the water droplet containing salt settle in a desalter. How would the settling rate of these droplets change if the viscosity is reduced to 1/3 times by increasing the temperature? So here using the formula as I told in the theory part, which is nu equal to 2r square delta rho g upon 9 theta, which is viscosity. So here we can see this is a settling velocity. So here we can see settling velocity is inversely proportional to viscosity. So V2 by V1 would be eta 1 by eta 2. So eta 2 is 1/3 of eta 1, which is reduced by 1/3. So eta 1 upon eta 1 into 3. So V2 will be thrice of 1, that is triple. So velocity will be triple of the initial velocity. Coming on to the next question, which is the same amount of aniline and lube is heated under specified conditions, and these are mixed at 80 degrees C. So in the last numerical, as we saw, this is the aniline point, which is 80 degrees C. So we have to convert it into Fahrenheit. That is 18 to 9 by 5 plus 32, which gives 176 degree Fahrenheit. Now calculating the API as specific gravity is given 0.90, so it will be 141.5 upon 0.90. 141.5 upon 0.90 minus 131.5, which gives 25.72 degree API. So the diesel index is API in Fahrenheit, sorry, aniline point in Fahrenheit into API gravity upon hundreds. So it will give 45.27. Diesel index is 45.27. Coming on to the next question, which is in which technique crude oil is separated? So as we have seen in the theory that crude oil separation takes place from fractional distillation, so the answer is fractional distillation. Coming on to the next question, which is the API gravity of natural gasoline and kerosene are 85 and 55 respectively. Determine the difference in their specific gravity. It is similar to the first numerical we did. So the specific gravity for 85 degree API would be 145 upon 141.5 upon 131.5 plus 85, which gives 0.6536, and specific gravity for 55 degree API is 141.5 upon 131.55, which gives 0.7587. So the difference would be 0.7587 minus 0.6536, which gives 0.1051. So the answer is 0.105. Coming on to the next question, which is the table shows the octane number of some hydrocarbons. Hexane has the lowest octane number of the four compounds. What structural feature of the hexane contribute to this? Hexane has a straight chain. It does not contain oxygen. It does not contain lead. Hexane contains a ring structure. So the containment of the oxygen or lead does not affect the octane number. Basically, so the B and C is not correct. Hexane contains a ring structure, which is not correct. Hexane has a straight chain. So the answer is hexane has a straight chain. Therefore, it has the lowest octane number. Research octane number and motor octane number is measured at dash and dash RPM respectively. So during the octane number part, I told you that research octane number, which is practiced at lower RPM, which is 600 RPM, and motor octane number at higher RPM, which is 900 RPM. So the answer is 600 and 900 RPM. So this is the last question for the day. So these are all the questions for the day. So did you guys get all the questions? Okay. API gravity basically uh, it is basically related to the density of the crude oil. It is basically a measure of the density of the crude oil. So lighter the API, so the higher the API gravity, that means the lighter the crude oil. So basically the LPG has the LPG, which is the lightest part of the crude oil. It has the highest API, and it is basically given by the formula 141.5 upon specific gravity at 60 degree Fahrenheit minus 135.5 if, and the API gravity also tells us about the quality of crude oil. So as the API gravity increases, you can say the quality of the crude oil also increases. Is it clear to you, Ruchi? Anyone else? I hope all the numerical questions are clear to you.
Yes, ma'am.
Okay, so should we end the session for the day? These slides will be available to you. The link to the slides as well as the link to this class will be available. I mean, this class will be uploaded on the YouTube, so you can see it again for your reference if you need. So I guess we are done for the day. Anyone, please, if there is some question they can ask, or we may end the class. Okay, then let us all meet next week. Okay, then let me end the class. At least say yes or no, someone.
Okay, ma'am.
Okay, thank you.